To group categorical variables, first click on the variable you want to group. Click the Create var button like we did in the earlier video, and then this window will pop up. Name the new variable, such as grouped highest grade attended, and then assign new names to each level, like this for example. If you assign the same name to 2 or more levels, they will become grouped together under this new name. Then click the Create Variable button. It's that simple. Then you can fit this new variable in the model the same way as the old variable when you click Fit GLM. For starters, you can group levels with small numbers of records in them, or cases in them, to make things easier to work with and help the models converge. If, when you click Fit GLM, you get messages like GLM diverged, it's probably because of difficulty dealing with levels with small sample sizes. The other reason you would want to group levels like this is when 2 or more levels are similar to each other and might have similar betas. For example, in highest grade attended, the 9th through 11th grade has a similar beta to 12th grade. Maybe it makes sense to group these together into one level called 9th through 12th grade. Similarly, graduate school and 4 years of college look to be at a similar level. You can see the line is almost flat, so these could be grouped together. Grouping categories like this serves 2 purposes. Firstly, it leads to a simpler model. The simpler the model, the fewer parameters it needs to estimate, the more accurately it can estimate them, since it has more data within each category on which to base its predictions. There would be more people in the 9th through 12th grade category than there would be in either the 9th through 11th grade or 12th grade alone, for example. The more records or cases in any group, the more certain you can be about the conclusions drawn from it. At one extreme, having just 3 categories, high school, some college, and graduate school, is simpler to work with, easier to understand, and easier to explain than a model at the other extreme, where each high school grade 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 1, 2, 3, 4 years of college are all separate categories. Add graduate and technical school on top of that, and you're talking about at least 18 categories, each with a relatively small sample size in each one. Where you have only 3 categories, each with many respondents in each one, you can draw some good conclusions about each category. Recall from earlier that confidence intervals tend to be tighter for categories with more records or a larger sample size. Ask one person how much they spend on gambling per year and you could get any answer. Ask 1 million people the same question and take the average of that million, and you can start to form some solid conclusions about the whole population from that sample. Where you have 18 categories, some of those categories might not have any respondents in them, and the betas could be all over the place. However, grouping categories together can hide interesting features, unfortunately. Maybe there is a genuine difference in gambling problems later in life between those who left school between 9th and 11th grades and those who left in the 12th grade. Grouping those categories would hide those differences from you. So there's clearly an optimal level of grouping somewhere between those 2 extremes that you can arrive at by looking at these charts, as we are doing. For the sake of illustration, let's create the following groups. 1st through 8th grade. They clearly stand on their own, with a beta parameter much higher than any other level. 9th to 11th grade and 12th grade we can group together. 1 through 3 years of college and technical school we can group together. And recall from an earlier video that this category also includes those very small number of cases who refuse to answer. And we can group 4 years of college and graduate school. So let's create var. Call this 9th through 12th grade. Call this 1 to 3 years plus tech. Copy that here, and call this 4 years col plus grad. and 1 to 3 years of tech is refused. We'll name this grouped highest grade. So this category now appears here as grouped highest grade attended. Let's put this one in the model instead and click Fit GLM. So you can see we have now here 4 categories and 3 beta parameters. 1, 2, 3. Since the base level doesn't need a beta. And the categories are much more distinct from each other now. The betas don't sit inside each other's confidence intervals. Betas for any predictor can shift around as you add, remove, and group other predictors. Remember that the model fits all your predictors simultaneously. So if you add in another predictor that better explains the response variable, then an earlier set of betas for another predictor variable will shift around, maybe moving closer to 0, or the confidence intervals expand. When the original levels are selected, the beta for the group is displayed for each of the constituent levels. You can see there's a flat line there, a flat line there, and a flat line there. We can see here the same beta value applies for 1 through 3 years of college, refused, and technical school. And the same value applies for 4 years of college and graduate school, etc. There are no confidence intervals shown here though, because this raw variable wasn't the one that was included in the model. This grouped one was. Note as well that the base level has changed. Under the raw version, 1 through 3 years of college has the most number of records, or the highest sample size. Barely. But when we group the levels together, 9th through 12th grade is now the biggest category, and therefore this is the base level, where the beta is 0. When you create a new variable like this in one workspace, it will become available automatically to all other workspaces in the dataset. So if you create one under Gambling Problems Lifetime, it will automatically be available for use in the Gambling Problems Last Year workspace, if we were to switch over to that. Now you are under no obligation to use this new grouped predictor in any other workspace, although if we just switch over, you'll see that it now appears here, and you can click it and include it in the Fit GLM if you want to. If you don't like the grouped version anymore, or want to clean up your left panel, then just click on the version of the variable you want to delete and press the delete button. We might not want this middle one anymore, where we grouped refused, because we are so happy with this new version that we've just created. So we might want to delete this older version. Just be aware that since creating a variable in one workspace will make it available to others, so too does deleting it in one also remove it from all workspaces. I won't delete this one now though, but to play it safe, you can always just keep your variables there and just not tick them, which means they're always ready and available in this workspace and any other, but they just won't be included in any actual models and no parameters will be estimated for them.